Okay, let's review ES logarithms. So first, we're going to work on condensing. So you should already know your laws of logs. We are just reviewing. The first thing we always look for when we're condensing is the coefficients. We do those first. Coefficients float up and become exponents on that term. Then the other thing we know is that when we see pluses and minuses, we're going to have a fraction. The ones that are positive will end up multiplied together on the top. The ones that are negative will still end up multiplied together, but they will be on the bottom. So we have plus means multiply. Log base 3 of x squared plus log base 3 of y is going to be log base 3 of x squared y. Minus log base 3 of z squared minus log base 3 of 5 is going to be 5z squared on the bottom. Notice it still has the log base 3 in the front, and we have condensed it to a single logarithm. See if you can do the next one. Find the coefficients first, float those up, make them an exponent. That's 2 cubed, which is 8. Plus means multiply. So I'm going to have log of minus means divide. The multiplied ones end up on the top, multiplied together. The minus ends up on the bottom. 3 times 8 is 24. And then divided by 5, log of 24 divided by 5. Okay, moving on to evaluating. Hopefully you can do these in your head at this point. We should have done a lot of logarithms. And what people think to themselves when they see number 1, it's red, log base 5 of 25. They think to themselves, 5 to what power makes 25? Because they want to know what it equals, swoop and change it to an exponent problem. This is what people are thinking to themselves, and the answer is 2, because 5 squared is 25. Equals x, 3 to what power equals 1 over 27. To get a fraction, your exponent needs to be negative, and 3 cubed is 27, so negative 3 will give us 1 over 27. See if you can do number 3. 7 to what power equals 1 over 49? The power must be negative 2. Negative to make a fraction. 7 squared is 49. Moving on to number 4. Now the base is bigger. 81 to what power equals 3? Well, that's kind of weird, right? Because you don't want to multiply 81 times itself. You'll never get 3. That's because you need to root, some sort of a root, the 81, right? If I changed it to 3 to what power equals 81, you should know that one. This would have an answer of x equals 4. So the one we're doing must be 1/4. The 4th root of 81 would give you 3. So the answer is 1 over 4. Number 5. See if you can do number 5. The base is bigger, so it's going to be a fraction for an answer. Because if it was the other way, 5 cubed is 125. So if the base is 125, the answer must be 1/3, the cube root of 125. Number 6 is kind of putting some stuff together. Condense first, so minus means divide. You can start as a fraction, but 100 divided by 4 is just 25. Then equals x, change it to an exponent problem. 5 to what power equals 25? The answer is 2. So condense first and then evaluate. Okay, moving on to solving. So there are 3 different types of equations we would have to solve. The first one is like this one, where every single term has a log attached to it. So our goal when every single term has a log attached to it is to get it to log of a equals log of b, because then naturally the a would equal the b. But only once you get it down to log of a equals log of b. So that means we have to condense. Subtract means divide. X over 2, log base 2 of x over, let's not change the problem, 3, equals log base 2 of 7. So now that it has log base 2 equals log base 2, The insides must be equal. Multiply by 3 to get rid of the fraction. X equals 21. See what you can do with number 2. Condense first, and this one has a coefficient, so that's first step. Make it squared. So this is log of 3 squared is 9, plus log of x equals log of 5. That's one step. Notice how the logs are all still there. Then addition means multiply for logs. Log of 9x equals log of 5. Now I have a log equals a log. 9x equals 5. Divide by 9. X equals 5 over 9. Logs on both sides. Condense them. Get it to be log A equals log B, and then you can solve. The second type. Some of them are logs. Some of the terms have a log on them. Some of the terms are just a number. Our goal is to get it down to log base B of A equals n, right? I'm calling n the number. Once we get it to there, we can change it to an exponent problem. B to the nth power equals A, and then we'll be able to solve from there. So first we have to get it to log of A equals n. So first we have to condense. Condense, I still have log 2 written down. Subtraction for logs means divide. 5 over x equals 3. Now I have it to log base B of A equals n. Now I can change it to an exponent problem. 2 cubed, I'm just going to do that, right? 2 cubed is 8. And it equals 5 over x. Multiply both sides by x to get rid of the fraction. Then divide to get x. X equals 5 over 8. Number 4, all your numbers need to be on one side. A log equals a single number, so add the 1. Log base 3 of x plus 1 equals 2. Change it to an exponent problem. 3 squared equals x plus 1. 3 squared is 9 equals x plus 1. Minus the 1, and x equals 8. More of the same, right? Logs and regular numbers. Condense. Log base 3 of. Plus means multiply, and when you have more than one term over here, you need to distribute the 2 to both terms as you multiply. So that's log base 3 of 2x plus 2 as I distribute. Then change it to an exponent problem. 3 squared equals 2x plus 2. 3 squared is 9 equals 2x plus 2. Minus the 2, minus the 2, and divide. X equals 7 divided by 2. Okay, on number 6, I see a coefficient, and I understand after everything I've been teaching you, if you think you should move that coefficient and make it an exponent. But that's going to make it x plus 2 cubed, and that's going to make it harder. Don't forget, sometimes it's more helpful to have it in the front. So right now it's 3 times log base 4 of x plus 2. Well, if I want to move that 3 to the other side because this is an equation, I can just divide by 3. And I'll have log base 4 of x plus 2, because those 3's cross out, and it'll just equal 3. So it makes my numbers smaller. Then I change it to an exponent problem. 4 cubed equals x plus 2. 4 cubed is 64 equals x plus 2. Minus the 2, and x equals 62. So sometimes it makes more sense to divide once you get the log alone. Okay, this is our third type. In our third type, our goal is to get a to the x alone. It's not going to be that simple. And then we're going to go from exponent form to log form. So the base is a, so it's going to turn into log base a, and then it's going to be of b, and it's going to equal whatever the exponent is. So first thing we need to do is get it to a to the x alone. So this 5 to the x plus 3, we need to get that alone. And we can't change the 5. You cannot distribute the 2. Instead, you want to divide by 2. Get the 5 to the x plus 3 alone. Now see if you can change it to log form. The base is 5, so log base 5, subscript of 5, of 6, and it'll equal the entire exponent. So in this case, it equals x plus 3. To finish solving, minus the 3 from both sides. Log 5 of 6 minus 3 equals x. You can't actually subtract the 3, so that's what your answer looks like. See if you can do number 8. Add the 4, get it alone. Change it to a log. Log base 9 of 7 equals x minus 3. Add the 3, and x is going to equal log base 9 of 7 plus 3. Okay, 2 more for you to try. So get the base, the 6 alone. Add 1. Divide by 2. Change it to a log problem. The base is 6 of 7. This time it equals 2x plus 3, so it still kind of has a ways to go. Minus the 3. Remember, you can't actually subtract it, so it's going to be log 6 of 7 minus 3. But now it equals 2x, so to finish solving, you have to divide by 2. So your answer is going to look like log base 6 of 7 minus 3 all over 2. Nothing simplifies, nothing combines. That's the answer. See if you can do number 10. I'm going to pause the video and just show you my work for number 10. Pause it and try number 10. Okay, check your work. Add the 1, divide by 3, change it to log base 4 of 3 equals x minus 2, and then add 2 for your last step. Okay, the last thing we do is graph logarithms and state the transformations. So we have a couple things we need to find. We need to find the asymptote and the locator point. This problem says x minus 3 in parentheses. That means x equals 3, positive 3, zero product property, is going to be my asymptote. Add 1 to that, and you get 4, comma, and then our k value is 1 for this equation, so 4, comma, 1 for this. So I have some positive space, so I'm going to go here. So my asymptote is at positive 3. I'm using my graph paper, 1, 2, 3. Dotted imaginary asymptote, straight line. And my locator point is 1 to the right of that, 4, 1. Hug the asymptote, really slowly increase to the right. My transformations, the minus 3 moved it right 3, and the plus 1 moved it up 1. See if you can do number 2. Asymptote. Locator point. Transformations, and a sketch. So it says plus 2 in parentheses, so x equals negative 2 for the locator point. 1 unit to the right, add 1, negative 1, comma. Coincidentally, the k is also negative 1. So negative 2 for the asymptote. Negative 1 for the locator point. Hug the asymptote, super slowly increase. Plus 2 in parentheses moved it left 2, and minus 1 moved it down 1. Hopefully this helps, and I hope you do great on your ES logarithms.